Alright, welcome to everybody to a summary video of just the concepts of Chapter 3.1. This is College Algebra, Introduction to College Algebra, Math 141 in UW-Whitewater, in case anybody's looking at it. So we're taking a look at the concepts. The concepts are just basically taking a look at the information that's given to us in a model of exponential, an exponential function. If we've got an exponential function that's listed as n of t equals 200 times 1.8 to the tth power, that fits into our f of x equals c times a to the x power. And that means that c is 200. That means my starting amount is 200. My a, my growth factor a, that I multiply everything by, that I multiply an example, that I multiply a value in my table of values to get to the next value. That's what's called the growth factor a. That a is 1.8. The f of x explains, hang on one second, explains our exponent. And when we've got an exponent in our, or when we've got a variable in our exponent, that means we've got an exponential equation. So this x becomes a t in our equation, and the f of x becomes n of t. So initial bacteria population is our c value is 200. In this case, it'd be 200. Growth factor, and I always recommend mentioning growth factor a, because that way you keep growth factor a compared to growth rate r different. So growth factor a here, if we write out our c times a to the x power, a becomes 1.8. Growth factor a is 1.8, and that's the number that we multiply by. That's the number that we multiply an entry in our y value by to get to our next y value. Growth rate is related to our growth factor a in the equation a equals 1 plus r. So if I have my a of 1.8 equals 1 plus r, then I've got 1.8 equals 1 plus r, and my r, then if I subtract 1 from each side, and I get 0.8 equals my r. R equals 0.8. Growth rate r is 0.8 in decimal form. Growth rate then in percent form is, instead of 0.8, from 0.8 of a rate, we multiply by 100% to get 80% growth rate. And there's our growth rate. And there's really a couple different descriptions of, or pieces of information that we can get from n of t equals 200 times 1.8 to the tth power. So we can go back and forth. If I give you this blue equation, we can pull out all the information. 200 is our starting value. Growth factor a that we multiply successive amounts by to get to the next value is 1.8. Growth rate is 0.8%, 0.8 in decimal form, and the growth rate in percent form is 80%. These all work together in terms of like x and y tables. If I've got an x and y table, and I start at 200, if my x value is 0, then my y value is 200, because if my x value, I guess in this case it'd be t value, if my t value is 0, 1.8 to the 0 power is 1. 1 times 200 gives me 200. And now if I put in x equals 1, I multiply 200 times 1.8 to get 1.8 times 2, let's see, 360, I think that's right. 1.8 times 2, 360. That gives us our next value of 360, and that tells us that our next value is 360. If we were given just the table, we could find out that our a value would be 360 divided by 200 equals 1.8. In this equation, or in this situation, a is definitely greater than 1, so that means that if a is greater than 1, that we have growth. We don't have decay, we have growth, because every time we move forward in the x, or in this situation the t value, every time we move forward in the x, we're getting a larger value for y, so our graph would look something like this. Because a is greater than 1, if a is greater than 1, then our r is also greater than 0, so that means that r is greater than 0, and therefore we also have growth. From either one of these situations, a is greater than 0, a is greater than 1, or r is greater than 0, then we have growth. And that's kind of a summary of what our concept is for basic exponential functions.